we do infrastructure. And I think it's worth taking a high-level view to ask, what is infrastructure? What is the difference between infrastructure and construction, and what is the relationship between them? So infrastructure involves building physical systems. This is what you construct. This is really important. Everything is mediated through this. These physical systems involve lots of technologies in both the design and engineering and construction of them. That's what we're talking about in this room. That's all very exciting. That's very relevant. But infrastructure goes beyond this. You're not just building physical systems, you're building economic systems, you're building political systems and legal systems and social systems. And often you're working on such a large scale that environmental systems start to come into play. Not all of your stakeholders are human, and you have a lot of stakeholders. You have a lot of different jurisdictions that you operate in. That's what makes something infrastructural. And this country really is a pioneer in doing amazingly innovative infrastructure. To have a good example of that, you need to look no further than 187 years ago. So the first modern railway was built in 1830. And this really set the pattern for essentially all railways in the future to the present day. By 1852, the majority of railways that now exist in this country had been built. That was 22 years to build basically the national rail network. Now, of course, we didn't stop there. We kept going. And today we're doing some really amazing projects. And you're probably this week going to hear a lot about Crossrail. And Crossrail is exemplary. It's a really incredible project. It's 10 years of extremely sophisticated tunneling and modeling and project management, and it's coming together really well. It's a great project. I don't mean to be critical in what I'm about to say next. But the story of Crossrail is not the story of the last 10 years. The story of Crossrail starts when the first person said, hey, maybe we should build this thing. Unfortunately for them, that was in 1941. London spent the next several years preoccupied with something else. But by 1948, Parliament actually set up a commission to investigate. I don't know, should we build this thing? And the commission worked on it for a while, and then we worked on it for a while longer. And in 1974, they came to an answer, which was yes, we should, and we should call it Crossrail. But where should it go? Well, I don't know. Let's have another meeting. So they had some more meetings, and by 1989, they narrowed it down to 3 options. Okay, and then they had some more meetings, and by 2005, they had one option they could ask Parliament to build. And Parliament had a few meetings, and by 2008, they said, all right. And then the contracts went out and construction started, and it's going really well, actually. That's great. But this is 78 years from start to finish. And 16 billion pounds. And this is a good project. This is a really good project. I'm from America, right? I grew up in California, in Silicon Valley, actually. In America, we have a subway in New York that took 98 years to build, just opened at the beginning of this year. It only has 3 stations for 98 years. In California, we've got a high-speed rail project that's $50 billion over budget. So this is fine. This is really good. This is not a problem. But it would be nice if we could do infrastructure projects in less than 68 years to figure out the why and the wherefore. That would be really good. So what has happened? How come we could build an entire national rail network in 22 years, almost 2 centuries ago? And it takes 78 years to build a really cool single rail line in London today. Well, running out of money is not one reason. It's not a financial issue. Okay, when the national rail network was built here, the UK economy adjusted for inflation was 33 times smaller than it is today. So that's not the problem. The problem actually is that everything's just gotten a lot more complex. The technology is a lot more complex. There's a lot more experts that have to coordinate on it. Society has gotten a lot more democratic. You can't just sort of shoo people out of the way if you want to build something. So a lot more stakeholders to consult. A lot more transparency is demanded by the population. And these are all great things. This is all really good, but the result is there's a lot more cooks in the kitchen, and the number of communications that happen between them has exponentiated, and project management hasn't kept up. So we all talk about digital tools and how those tools sort of coalesce around special silos for different disciplines, and then they communicate with each other very badly. And this is a problem that we need to fix. And everybody in this room is interested in fixing it, and some of them have come up with solutions very similar to what we've come up with. And this is all great, but I tell you this story by way of reminding you of the big picture. Because we need to be thinking about why we're doing this. We're not just trying to build better tools, we're trying to make a better world out of that. And how much better can that world get? Well, McKinsey did a fairly amazing study where they looked at infrastructure projects around the world. They did a root cause analysis of the cost overruns for 400 major infrastructure projects. And they came to the conclusion, first of all, that the world was spending about $1 trillion a year more than it had to on infrastructure, or alternative way of looking at it, the world was getting $1 trillion a year less infrastructure than it ought to. Most of that cost overrun was accrued in the construction phase of the project, okay? But actually the root cause of it wasn't in construction. The root cause was way upstream. And that's actually the area that interests me the most. So McKinsey concluded that 60% of the cost overruns and delays were due to early stage communications failures between people who just should have talked to each other in the conceptual phases of the project and didn't, and then everything went badly later. So you've got the project lifecycle here, and basically this is where you need to start collaborating. And you need to keep collaborating throughout, but there's not a time when you introduce collaboration into the process. It really should start at that first napkin sketch at the bar in 1941. So another thing, beyond just cost overruns and delays and so forth, another thing that I think really suffers from lack of early stage collaboration is creativity. If you are trying to conceptualize a project, the safest way to keep things from going belly up is to make the most conservative assumptions, to do basically the stupidest thing you can possibly do and assume that everybody else is doing the same. And that really limits the innovation potential for infrastructure. This was a project that I actually ran in India, looking at autonomous vehicles in Delhi. It was an amazing coordination problem between planners and engineers and policymakers and neighbors and everybody else. And ultimately, it's probably not going to happen. But it could only happen by virtue of people talking to each other in the knocking ideas around phase of the project long before you ever get to the construction side of things. Without that early stage collaboration, you're not going to see crazy driverless pods or hyperloops or anything else that's really that innovative. In order to break the boundaries between all of those disciplines and actually disrupt across disciplines, you've got to have collaboration. So it's about creativity. Anyhow, this is what my company does. This is what we created. To start with, it's a web-based planning and engineering tool for really early stage feasibility planning for public transport infrastructure, because that's my background. That's what I know well. Crucially, it happens in a web browser so that anybody can use it. Equally crucially, it's extremely multi-user so that you can have a large number of collaborators working on the planning and engineering of a transport network and immediately bouncing ideas off of each other and seeing what they're doing. Equally crucially, this isn't just sort of a video game like SimCity for real cities. It's actually doing robust version control. Each and every entity in this model has its own version history, so you can do things like nonlinear rollbacks of specific sections of the networks and so forth. So yeah, it's meant for early stage knocking ideas around, rapid iteration, agile collaboration across disciplines. The software has a few different faces. It has a face that it presents to planners and engineers who are very technically oriented. It has a face that it presents to non-technical stakeholders where they can leave georeferenced comments on the map, so you can engage your non-technical stakeholders at the earliest stages of project development. That's the idea that we're developing. And yeah, I'm afraid that Flux has stolen a bit of our thunder with some lovely convergent evolution here, because we've really come to a very similar solution in a lot of respects. The way we do this is not by synchronizing files. We think that files are just so 20th century. They're not really the right metaphor for projects. Instead, we synchronize data directly. We actually have very sparse data. We're not big data. The data is sparse so that it can be synchronized as rapidly and pervasively as possible. What we model with our data is are the things that all the different stakeholders need to agree on, rather than the things that all the different stakeholders need to know individually. So the nuts and bolts can stay in AutoCAD Civil 3D, and some of the demographic data can stay in ArcGIS or whatever. But we want to model the intersection between them and make sure that everybody stays synced up. So yeah, we sync the data in real time. We take those feedback loops, which in early stage feasibility studies, those feedback loops can sometimes take months or years. We take about 1,500 milliseconds, and we store it in the cloud, single source of truth on the cloud, whatever truth is. We expose it via web browsers for visualization, feedback, high-level project design and management, and so forth. That's what we do today. Our roadmap in the really near future at this point is to expose that data through public APIs, so that third-party desktop applications can take advantage of the same sort of synchronization. Very Flux-like, actually. Our first API is starting a private beta this week, so that's exciting. And with planning now being done on the cloud, there's all sorts of third-party data sources and simulation as a service and all sorts of other things that you can start to do now that everything is designed to be interoperable from the beginning. So this is not an ecosystem we invented. This is one we stole, which is apparently what great artists do. Basically, the idea is that we're taking the principles from agile software engineering and trying to apply those to infrastructure planning. Through that sort of agility, we hope to foster both more accurate projects, more cost-effective projects, and also more creative projects. So our MVP is currently placed at the earliest stages of the project lifecycle here, but we think that the real-time collaboration mechanism through APIs can extend our utility all the way through the project lifecycle. And I'm sure at some point we'll be syncing up with Flux on this, because we definitely will run into each other eventually. So that's Podaris. Thank you very much.
Thank you, Nathan. Does anybody watch Bake Off? You know, the Paul Hollywood character? Anybody nod? No. Basically, when he sees something so impressive, he gives him a handshake like that. That's exactly what I like there about that. So, questions for Nathan, please. Go
on. I like the fact that you say that you're going to see your information going all the way through the life cycle and staying there, because as purely observation of working on some of those projects, when you get to the end, they want it as simple as it was when you started. So you go through all this complexity and then they say, right, now make it as simple as it was in the beginning so we can understand and then continue to use it and then let it get complex again. So are you thinking around those terms as well?
Yeah, absolutely. When you saw in the sped up demo there that the planners are drawing lines and those lines are automatically generating curves, those curves are not geometric objects. They're rather sophisticated parametric models that are based on the actual engineering properties of the system that they're trying to model. So you can model with a high order parametric. For example, let's say you want to build a metro system, and you're a planner, you're not an engineer, but you draw some lines on the map, and this will say, right, these are the curves that you need to have, these are the velocity constraints around those curves based on lateral acceleration limits due to passenger comfort and stuff like this. This is how fast the vehicles can accelerate, how long they have to stay in stations, et cetera, et cetera, et cetera. And based on this kind of geometric constraint solving and kinematic profiling and all of this other stuff, you end up with a pathway for this that if you were to build that first napkin sketch, it would work. It's physically accurate enough to work. So you can do that first as a generic model, and then you can swap out the parameter set and say, right, this generic envelope allows us to conduct a tender from many potential bidders. What happens if we use trains from Siemens or Bombardier or Hitachi or whatever? And you can rapidly see how different parametric sets would affect that constructed model. But the ideal is that what you start with in the napkin sketch ends up being directly traceable to the final built product. Now, going forward, that very sparse model, which is defining that parametric system, should be kept in sync with everything as the construction details go in, right? And if the construction details start to violate some key parameter of that model, you have a problem, because that's defining what you can physically do, and you're not allowed to violate that, right? So, and if they change it, well, then great, the model changes, and that propagates to everybody else who's using that model. But yeah, I mean, the ultimate objective would be to sketch out a piece of infrastructure, have the parametric system engineer it, and then just hit the print button and get your infrastructure. But that will be a while. But we definitely want that traceability.
Any other questions? So it made me think of something else, actually. The way in which Arup produced the environmental statement for HS2 was very, very data-centric. They basically used geospatial, mapped everything, then used algorithms and routines to do how far is that line, or option 1, 2, 3, 4, from a heritage site or from a site of special scientific interest. And then, of course, the outcome had to be put it in a table in a PDF, which they digitized also. Yes. But then what that resulted in was 50,000 pages of an environmental statement which had to be read by other people. I'd like to think that that could overcome that. If you could bidirectionally do those, then you wouldn't have to do options. Maybe what you could do is recursive algorithms to say, actually, the best fit, if you don't want to cut down woodland, is self-generated.
I would, is this working? Woohoo! Yeah, I would very much like to see that as well, with the caveat that I think kind of auto-generated
needs an engineer to check.
Yeah, and so many of the constraints are ultimately political constraints, cultural constraints, stuff that is not going to show up in your data. So having human eyeballs on it at all times, I don't think that's going to change with all the machine learning in the world. But that issue of doing these incredibly sophisticated models and then printing out a 50,000 page report is one that I think we still face. If I'm honest, the biggest challenge that we have going forward is a cultural challenge with the industry, which is, we spent the past couple of centuries learning that having more cooks in the kitchen is a real pain in the ass, avoid it at all cost. And so the entire sort of mechanisms of the industry are designed to put checks and balances on when information gets released and to who, and make sure that it doesn't get out of control too early. And that really inhibits a lot of people's ability to say, hey, I've got an idea, I'd like to bounce off somebody who's an expert in this thing, why don't I just invite them in to collaborate with me? So we have a big culture change project ahead of us as an industry to actually embrace collaboration, embrace transparency as something that can be a benefit and not a cost. Until these digital tools were available, it was a cost for a good reason, but that has changed, and we need to wake up to that.
It's absolutely changed on its head. And I think one of the points that came out from the ICE conference on Friday was changing the commercial model into an outcome-derived commercial model. And not just for the work in hand, but actually a societal outcome. Basically, it's the best thing to do for the country at large, for the, as you were making at the beginning. Anthony.
So this is a question from a Brit living in California to a Californian living in Britain. I mean, it's undeniable the kind of the technology companies and the impact they're having here in the UK, and Flux is coming out more and more frequently just because of the demand out here. Yeah. Why did you choose to locate your company here and not in Silicon Valley?
So I'm interested in so the question, was why here and not Silicon Valley? I'm interested in public transport. I'm an architect and an urban planner by background. I'm really interested in public infrastructure. And to be honest, America is terrible at it. Yeah. It's just too based around the car. People take cars very seriously, and public transport is a SOP for special interest groups, and that's the only real attention that it's given. America is actually getting better, I think, in recent years. Elon Musk is just kicking over everything he sees, and I like that. I'm not sure how realistic it is, but I like it. Somebody had to do that. But at the time I left 10 years ago, I was particularly interested in autonomous transport and how that could shape the urban environment. I joined the company that made the pods at Heathrow. Everybody, yeah, you know the Heathrow pods. They're really cool. Anyhow, that was my first project in transport in the transport space, and then I was put in charge of taking that technology into wider urban environments. And it was in failing to do that I started to think, hey, actually, the planning and engineering and design tools and collaboration tools that we have need an upgrade to enable this sort of innovation. But really, yeah, it was Europe and Asia is just much better at this class of infrastructure than America is, and the pubs are better here than in Singapore.
Amen to that. I'm afraid I'm not going to take any more questions because I'm getting the clock ticking thing getting pointed at me. But I think it was a really good point to finish on, that we here, Britain, seem to be incubators for this area. We've seen it from Joseph and 3D Repo. We've now got our friends coming over from the States to join us here. It's a really good note to finish on.